Hi students, welcome to Max Point of View. Today we are going to understand the concept of calorimetry part B. So in part A we have learned the concept, after that we have solved the theory questions, after that numericals. In the same way we are going to do that in part B also. First in this video we are going to understand the concept properly, then we are going to solve each and every theory question. After that we are going to solve all the numericals. So without wasting any time, we'll start with our concept. Now we'll start the understanding by the complete basic. Listen, first we need to understand what is change of phase. Change of phase is nothing but change of state of matter from one to another at a constant temperature. Keep that in mind. Change of phase is nothing but change of state of matter from one to another at a constant temperature, like from solid to liquid, or liquid to solid, or liquid to gas. Any change of phase at a constant temperature is called change of phase. Next, the temperature, listen, temperature remains constant during the change of phase. Temperature remains constant during the change of phase. Keep that in mind. Next, I'll give you one example for that. We can, what is the temperature of ice? That will be at 0 degree Celsius, correct? So we can convert this ice into water at 0 degree Celsius. We can convert ice into water at 0 degree Celsius. How can we do that? We can aramse maintain the same temperature, but we are going to give heat energy to ice. Heat energy to ice. When this ice absorbs heat energy, this ice will melt into water. But whenever we convert that water into steam, okay, the temperature will be at 100 degree Celsius. Then I told you at constant temperature, right? Listen, ice will convert into water, but this water will not immediately convert into steam. This water will convert it into boiling. Okay, once it melts, okay, we convert into boiling. The water boils at 100 degrees Celsius, and at the same temperature, if we keep on supplying the same temperature for a longer time, this boiling will convert it into steam. That is what I am saying. Temperature, where during the change of state, the temperature remains constant. Next, heat absorbs or liberated. When the object will absorb it, or when it will liberate. Liberate means rejected or given out. Okay, heat is coming out is nothing but it is liberated. It is taking some heat energy inside. That is nothing but it is absorbing heat energy. Listen, you take an ice. Okay, if you increase the temperature of ice, what happens? We are supplying heat energy, correct? We are supplying heat energy, so it absorbs heat energy, so and it melts. So when the temperature rises, it absorbs heat energy. And during the freezing process, assume we are freezing water. Okay, from water we know it will be in a normal room temperature, it will have some heat energy. Whenever we start freezing it, whatever the heat energy it has, it will be liberated, given out. Whenever the temperature reduces, the heat energy will come out of the body. Whenever the temperature increases, it will absorb the heat energy from the surrounding. Next, we'll talk about this one. This we have learning from 8th standard. Listen, solid to liquid, liquid to gas, all those names and definitions we have learned from 8th standard only. Listen, first I'll give you some examples. You can copy the same thing. How can we define melting? Okay, melting is nothing but the change. This is the process of change of phase from solid to liquid at a constant temperature. At a constant temperature. If you don't write this word constant temperature, you are never going to get marks. Okay, then what is the difference between melting and melting point? Melting is nothing but change of phase from solid to liquid. Melting point is nothing but the constant temperature at which, the first word should be the constant temperature at which the solid changes into liquid. So this is how all these definitions will work. Boiling, vaporization as one more name, that is nothing but boiling. Keep that in mind. Okay, vaporization as one more name, that is nothing but boiling. Next, so we'll talk about how much heat energy it will absorb and how much heat energy it will liberate. Very simple. Listen, First I have a ice. Okay, now I want to convert this ice into water. Assume while converting the ice into water, assume it will absorb 350 joules of energy. It will absorb 350 joules of energy. If you convert the same water into ice again, it will liberate, it will give out 350 joules of energy. While converting into one phase, how much energy it has absorbed? While converting into the same phase, how it will liberate the same amount of heat energy. Keep that in mind. Then pure substances. Pure substances are nothing but the substances without impurities. Without impurities. I'll give you an example. Ice. Okay, ice is a pure substance. If you add some salt, it becomes impure substance. So pure substances as, okay, same melting and freezing point. Pure substances will have same melting and freezing points. Keep this in mind. These are the some important notes. That's it. These are the basics. So after this one, now we are going to learn the graphical method. How can we understand the graph, so that whenever any graphical question comes in the board exam, we can easily analyze it. Now we'll understand the graph during the melting. That is nothing but heating curve of ice during melting. Listen, whenever you start giving the temperature to your ice, do you think the ice will melt immediately? No. Until the complete ice converted into water, okay, it will be at the same temperature. Keep this in mind. See, the ice will not convert into water immediately. See, assume this is the part of this is ice. When you keep on increasing the temperature, first this part, okay, this part will convert into water, and then this part, then complete ice. Until the complete ice melts, the temperature will be 0 degree Celsius. Keep this in mind. So this ice will not melt immediately. Assume you are keeping the constant temperature. The ice will keep on converting into water. Once the complete ice is converted into water, then the temperature of water will rises. Okay, it will keep on moving till 100 degrees Celsius. At 100 degrees Celsius, okay, assume it reaches 100 degrees Celsius. After reaching 100 degrees Celsius, it will be converted into boiling. Boiling is nothing but the liquid is converting into gas or vapor. Listen, we'll consider this as A, and this point as B, and this point as C, and this point as D. Now listen, when the temperature is at 0 degrees Celsius, okay, of ice, if you start giving the temperature, some part of ice will be converted into water. So from this point to this point, we have both ice plus water. At this point, the complete ice is converted into water. So here it will start boiling at 100 degrees Celsius. Keep that in mind. This is the heating curve of ice. This is how you need to understand it. Ice will not just suddenly convert into water. It requires some time. So until the complete ice melts into water, the temperature will be 0 degree only. That is why I tell you the change of state from ice to water, okay, at 0 degrees Celsius. Until it converts the complete ice into water, the temperature will be 0. That is nothing but constant temperature. Then we'll talk about change in volume. So how there is a change in volume during the melting. See, some substances like lead and wax. See, whatever the substances they have given in the textbook, based on that only they are going to ask in the board exam. Listen, lead and wax and some other substances, when you during the melting process, the volume keeps on expanding. The volume expands, the volume increases. Expands means the volume expands. But in case of ice and bismuth, okay, bismuth is also one substance like ice only, but only in these substances, okay, the volume decreases. The volume decreases. Why it is increasing? The volume expands, but in this case ice and bismuth, the volume contracts. That is why the volume decreases. That's why in lead and wax the volume increases. So if you know this much about melting, okay, then it is enough to crack any question. Now we'll talk about what is the effect of pressure on melting. See, very simple, you can understand by an example. Assume this is a block of ice. If you apply some pressure, this will break into some pieces, correct? It may be many different pieces. Okay, now when you apply a pressure, this ice will break into many pieces. Now which melts faster, this one or this one? The pieces, correct? So when you increase the pressure, okay, when the pressure increases, melting, okay, melting point, not melting, melting point decreases. So when the pressure increases, melting point decreases, it melts faster. But in exceptional cases, a few exceptional cases are there. Exceptional cases, nothing but lead and wax. Lead and wax, if the pressure increases, melting point also increases. So pressure and melting points are inversely proportional when it comes to ice, but when it comes to lead and wax, pressure and melting points are directly proportional. Now we'll talk about effect of impurities on melting. When you add something to a pure substance that become impure substance, how that will affect melting? See, again, melting point, okay, melting point decreases by adding impurities. If you add impurities to a substance, the melting point decreases. So this kind of concept we can use it in kulfi making. See, in kulfi making, along with the ice, they'll put some salt. Salt is nothing but an impurity. So when you add that impurity to ice, the melting point decreases, so that it can be strong. It can be strong for a longer period of time. So this concept, the concept of adding impurities and melting is used in the freezing of kulfis. Now we'll talk about vaporization or boiling. See, boiling or vaporization means the same, and definition for vaporization is nothing but definition of boiling. First, when it comes to definition, two types of definitions you can expect. What is vaporization or vaporization point, or boiling and boiling point? Okay, listen, how can we define boiling or boiling point? Boiling is a process of change of state from liquid to vapor at a constant temperature. This is boiling. How can we define boiling point? The constant temperature at which the liquid changes into vapor. This is nothing but boiling point. Now the definition is over. Now we'll talk about the pure substances. Pure substances without impurities, the boiling point, okay, boiling point and the condensation point. BP means boiling point and condensation points are identical. Identical means same. Or you can write it as identical. Anything is fine. Now we'll talk about heating curve of water. Very easy, and it is easy to understand also. Listen. So at room temperature, assume you take a flask, okay, any flask or any material, you pour some water in it. Now at room temperature, assume the room temperature is 20. Sometimes it may be 25 and sometimes it may be 30, anything that depends upon different places. Okay, listen, assume now the room temperature is 20 degrees Celsius. Now the water is at 20 degrees Celsius. When you increase the temperature of the flask by giving the heat, okay, the water inside the flask will keep on absorbing the heat energy, I told you in the basics, whenever the temperature rises, it absorbs the heat energy. Now the temperature of water will keep on increasing until 100. So it will keep on absorbing the heat energy. Once it reaches 100 degrees Celsius, so AB represents water only. Okay, here it is water. Okay, once it reaches 100 degrees Celsius, it starts boiling. It starts boiling. What do you mean by boiling? The water will start converting into vapors. So at 100 degree Celsius, once it reaches, it will not cross this 100 degree. Okay, it will start keep on boiling. If you keep on giving the heat energy, that is nothing but using the flame or Bunsen burner, anything. Okay, it will keep on observing the heat energy, but the temperature will not cross 100 degrees Celsius. During that time also, the water will keep on observing the heat energy. So even though the temperature doesn't change here, it will observe heat energy at 100 degree Celsius. Next, we'll talk about change of volume. What happens during the boiling process? When you boil, we'll take an example of water only. When you boil the water, the temperature will keeps on increasing. When the temperature keeps on increasing, the volume of the water keeps on expanding. So if boiling volume expands during the boiling. Next, effect of pressure. This is a very important concept. Why? Because based on this, some applications are also there. So if you increase the pressure, what happens to boiling? The boiling point also increases. So boiling point increases with increase in pressure. Keep that in mind. Boiling point increases by increasing the pressure. If you increase the pressure, the boiling point increases. I'll give you an example. We'll take an example of pressure cooker. In pressure cooker, when we lock it and seal it with the whistle, in local languages we'll call it as whistle only. So when we lock it and start giving the heat energy, okay, via gas or Bunsen burner, anything is fine. So it crosses the temperature. Okay, when the pressure increases, the pressure inside the cooker will be more than the pressure outside the atmosphere. So once you keep on converting that water into steam, the steam doesn't have any way to escape out of the pressure. When there is no way to escape, the pressure inside the cooker will build. That is nothing but vapor pressure. The vapor pressure on the liquid will be more than the atmospheric pressure. How many times more? The vapor pressure in the cooker will be 1.75 times more than the atmospheric pressure. So what is the advantage of this? The vegetables or any cooking items will cook faster, and after cooking also the heat, the temperature of the cooking material will remain hot, will be high for a longer time. That is the advantage of pressure cooker. But there is one problem when it comes to hilly region and mountains. In hilly region and mountains, the altitude will be high. What do you mean by altitude? The height. Okay, when there is an increase in height, what happens to the atmospheric pressure? Atmospheric pressure reduces. We know, we have learnt in 9th standard that atmospheric pressure reduces by increase in height. That's why in mountains the atmospheric pressure will be compared to the land, it will be very low. So in those kind of region, it is very difficult to cook. Why? Because the boiling point reduces than 100 degree. What is the normal boiling point of water? 100 degrees Celsius. In hills and mountain region, the boiling point reduces below 100 degrees Celsius. So the required heat to cook the vegetables or any other food materials will be not sufficient. Okay, that will not provide the sufficient heat energy required. So the cooking time will be little longer, and it is very difficult for people who are living in hilly region or mountain region. Now we'll talk about effect of impurities. When you add impurities to water, okay, you assume most of the time we'll add salt only, as in it is not an impurity, we'll add it for a taste. Okay, but what happens when you add salt to water? That is acting as an impurity. When you add it, the boiling point increases. If you add the impurities, what happens to boiling point? It increases. So what happens if the boiling point increases more than 100 degree, the food or vegetables will cook faster, faster and in a easier way. That is what exactly opposite happening in hilly and mountain region. Here the boiling point reduces below 100 degree, okay, because of the low atmospheric pressure. But when you add impurities, okay, the boiling point increases, so the food or the vegetables will cook faster in a easier way. So if you know all these things about vaporization or boiling, that is enough. You can answer any give reason questions. Now we'll talk about very important topic in this chapter, that is nothing but latent heat and specific latent heat. This, if you can understand aram se, you can solve numericals also. See, in this chapter the only simple numericals will be asked in the board exam, so don't worry about the all the numericals which is there in the textbook. If you can solve first 7, it is enough. You can solve any numericals in the board exam, so don't worry about the numericals. We'll learn it in one of our video. That video will also be available in the description box. Now first we'll understand the definition of latent heat. See, definition of latent heat is nothing but it is the phase of the amount of heat energy absorbed or liberated by a body during the change of phase. The amount of heat energy absorbed or liberated during the change of phase. What do you mean by during the change of phase? That is nothing but from solid to liquid, liquid to solid, liquid to gas, any change of phase at a constant temperature. That is the definition of latent heat. When it comes to specific latent heat, this is exactly like heat capacity and specific heat capacity. In the definition of latent heat, if you add by unit mass, then you will get the definition of specific latent heat. I'll define it now. The amount of heat energy absorbed or liberated by unit mass of a substance during the change of phase at a constant temperature. This is the definition of specific latent heat. Then we'll talk about the formula. See, for latent heat, there is no symbol, there is no formula. Keep that in mind. Okay, whenever they talk about latent heat or specific latent heat, we'll use the same formula and same symbol. Keep that also in mind. So specific latent heat is denoted as L is equal to Q by M. The amount of heat energy absorbed or liberated during the change of phase by a unit mass of substance at a constant temperature is called specific latent heat. This is the symbol for specific latent heat. Q is the amount of heat energy absorbed or liberated by unit mass. So the unit will be, see, according to this one, this is joule, and mass, it is kg, SI units. So SI unit of latent heat or specific latent heat is joules per kg. This is the SI unit. Joules per gram is one of other units or CGS unit. How can you convert 1 joule per gram is equal to 1000 joules per kg. Keep this in mind. See, when you convert gram to kg, you have to divide it by 1000 normally, correct? Normally, whenever we want to convert from gram to kg, we have to divide it by 1000. But gram and kg both are in the denominator, not in the numerator. That is why whenever you convert joules per gram to joules per kg, you have to multiply by 1000. Calorie per gram is equal to 4.2 joules per gram. If you want to convert this 1 calorie per gram to joules per kg, 1 calorie per gram, if you want to convert into joules per kg, that is 1000 joules per kg. That's it. So these are the units. See, these two units are enough. These are the conversion. This one you should know. Okay, if you leave these two also, that is fine, but this conversion and these two units you should know. Then we'll talk about the meaning. What you mean exactly by specific latent heat, because based on the definition we cannot understand everything all the time, correct? So what do you mean by specific latent heat of fusion? Or fusion means nothing but melting of ice. So specific latent heat of ice, okay, specific latent heat of ice is 336 joules per gram. Okay, this is the statement. What do you mean by this? Actually, the ice requires 336 joules of heat energy. The ice requires 336 joules of heat energy to convert from ice to water, at constant 0 degree Celsius as temperature. So at a constant temperature, that is nothing but 0 degree temperature, the ice requires 336 joules of heat energy to convert into water. That's it. Next, we'll go for this one. This is also very much important. Listen, which has more energy? When it comes to energy, we always talk about heat energy in this chapter. So whether 1 gram of ice or 1 gram of water, which has more heat energy? We always, the water will have more heat energy. Keep that in mind. Water will have more heat energy. So water, 1 gram of water, 1 gram of water at 0 degree Celsius, compared to 1 gram of ice at 0 degree Celsius. In these two cases, which has more heat energy? Always water will have more heat energy. Now we'll go for this question. Which requires more heat energy? Whether this one or this one. Anyhow, water already has some energy, but ice requires a lot of heat energy, to convert into water. So 1 gram of ice requires more heat energy, okay, then 1 gram of water at 0 degree Celsius. So these are meanings and these are some facts. Now we'll talk about kinetic model, that is nothing but average kinetic energy and average potential energy. See, this concept is also very much important for logical type of questions as well as give reason type of questions. Listen, average kinetic energy completely depends upon temperature. Okay, completely depends upon temperature. If temperature increases, average kinetic energy of the molecules of what? Of molecules also increases. These two are directly proportional. See, if the temperature of any object, okay, increases, then the kinetic energy, average kinetic energy of the molecules also increases. What do you mean by kinetic energy? The moment of molecules will also increases. Those two are directly proportional. But when they mention same temperature, I'll give you one example at the end, don't worry. When they mention same temperature or constant temperature, the average kinetic energy of the molecules does not change. So if they will only increase if the temperature increases. If the temperature decreases, average kinetic energy of the molecules also decreases. If the temperature is constant or same, then there will be no effect in the average kinetic energy. So you have to write average kinetic energy of the molecules will not change at a constant temperature. So this is about average kinetic energy. Now we'll talk about average potential energy. This is completely depends upon two things. One, intermolecular force of attraction. Intermolecular force of attraction. And separation between the molecules. These two are okay, these two are opposite, right? If the intermolecular force of attraction is more, that means they are strong, then the separation between the molecules are very tiny. If this is more, this will be less. If these two are inversely proportional. In the same way, average potential energy is directly proportional to separation between the molecules. Separation between the molecules is nothing but intermolecular space of the molecules. Listen, so average potential energy increases with increase in separation between the molecules. If the gap between the molecules increases, average potential energy will also increase. Keep that in mind. If you don't talk about this one also, that is fine. This is very much important when it comes to average potential energy. Average potential energy is directly proportional to separation between the molecules. So I'll give you one example. When you melt ice, okay, I'll give you here example here only. Ice at 0 degree Celsius is converted into water at 0 degree Celsius. Water at 0 degree Celsius. So what happens to average kinetic energy and average potential energy? See, in average kinetic energy, it depends upon temperature. See, in both the cases, do you see any change in temperature? Increase or decrease? The temperature in both the cases, it is same or constant. So no change in average kinetic energy. But when it comes to average potential energy, it increases. Why? Because when you start melting the ice, the volume increases. Instead of using the word volume, the separation between the molecules increases. So the average potential energy also increases. This is about kinetic model. If you know this much, that is enough. Now we'll talk about the natural consequences. Listen, natural consequences are very much important. Why? Because based on these concepts, they are going to ask give reason type of questions. In the this one theory solutions, whenever we get questions based on these natural consequences, we are going to skip answers in the theory solution video. Why? Because we are learning here in depth. Now we'll talk about how snow on mountain does not melt all at once. Why the snow on the mountains will not melt all at once? What happens if it melts? All those things we are going to learn here. First, specific latent heat. Specific latent heat symbol is nothing but L. So, specific latent heat of ice, of ice is 336,300 joules per kg. This you should know. What is the meaning of this? If you want to melt the ice, it requires 336,000 joules of heat energy per kg. To melt 1 kg of ice, it requires 336,000 joules of heat energy. So when all these heat energy, why the snow melts? Because it is getting the heat energy from the sun. So when the sun rises, it will absorb, this ice will absorb heat energy, slowly, so that the snow melts slowly. It will not melt all at a time. If the specific latent fusion of ice is less than this value, then because of the sun heat energy only, the complete snow on the mountain will melt all at once, and that will result in flood, and after that flood there will be no water for us. So that's why whatever happens on earth, everything is for a reason. So it is for good only. Now we'll talk about the next consequences. In cold countries, water in lakes and pond does not freeze all at once. That means the complete water in the pond or lake will not freeze all at once. At the same time, it will not freeze. Why? Because it has high specific latent heat of fusion. It has high specific latent of fusion of ice, that is nothing but 336,300 joules per kg. So this is the specific latent heat of fusion of ice, that is nothing but 336,300 joules per kg. Now listen what happens, why the complete water in the lake and pond will not freeze at a time. What happens? See, whenever it wants to freeze, it will releases heat energy from the object, from the water. Whenever it is getting freeze, the heat energy should go out. So the heat energy in the water will go out whenever it starts freezing. The top layer of the river or pond, or not the river, lake or pond, will freeze first because of the because it is releasing the heat energy. Once it releases, the top layer of the pond will freezes first, and the freezed ice, okay, the top layer ice is a very poor conductor, of heat. That is why the complete water in the lake will not be freezed all at a time. And one more thing I forgot to tell about the previous one, why the snow will not melt all at once. And one more thing, one important thing about that natural consequences is, whenever this one ice starts melting, it absorbs heat energy from the surrounding. That's why in a snow area you will feel very cold. That is the exact opposite to this point. Whenever the lakes, okay, or ponds are getting freezed, the heat energy will be released from the water. That's why during the freezing of lakes and water, the temperature of the surrounding will be warm. Now we'll talk about our next consequences. Drinks get cooled more quickly by adding pieces of ice than ice cold water at 0 degrees Celsius. That means ice at 0 degrees Celsius and ice cold water is also at 0 degrees Celsius, but we prefer pieces of ice at 0 degrees Celsius, okay, to cool the drinks quickly. Why? Because very simple. While learning the concept of specific latent heat, we learned one concept, that is nothing but 1 gram of ice at 0 degree Celsius requires more heat energy. This is very much important. More heat energy. How much is that? That is nothing but it requires 336 joules per gram. Per gram it requires 336 joules of heat energy compared to 1 gram of water at 0 degrees Celsius. 1 gram of water at 0 degrees Celsius is nothing but ice cold water only. So 1 gram of ice at 0 degrees Celsius requires 336 joules of energy. So if you add ice, okay, in the drinks, so what happens? From the drink it absorbs 336 joules of heat energy, okay, compared to ice cold water. Ice cold water will also absorb heat energy, but will not absorb 336 joules of energy. It will absorb less than 336 joules of energy. That's why we prefer pieces of ice than the ice cold water to cool down the drinks quickly. Now we'll talk about the remaining consequences. Very simple, listen. When ice in frozen lake, okay, assume the lake is frozen now. When it starts melting, its surrounding becomes very cold. Why? Because what you mean by melting? Melting is a process. It absorbs heat energy from the surrounding. This is very much important. While melting, it absorbs heat energy. While freezing, it releases heat energy. Keep that in mind. So when melting, it absorbs heat energy from the surrounding. That makes the surrounding very cold. In the same way, we have one more question. It is generally more cold after a hailstorm. Hailstorm is nothing but melting of ice only. The same concept. Okay, here they have added one condition. Okay, during the hailstorm and before the hailstorm, okay, the temperature will not be that cold, but immediately after the hailstorm, when the ice melts, the temperature will be very cold after the hailstorm. Why? Because during the process, it keeps on absorbing the heat energy from the surrounding. But before hailstorm, before ice start melting, the temperature of the surrounding will be more, okay, greater, so that it will be warm. Okay, it will be warm. But once the hailstorm is done, okay, after the hailstorm, it absorbs the temperature from the surrounding. That's why after the hailstorm, the temperature will be very cold in the surrounding. These two are the reasons. So if you know all these things, then we are ready to go for the theory solutions. So after the theory solutions, go for the numericals. See, first understand the concept. After the concept you have to go for theory question, because we know the concept, we have the knowledge, but we don't know what kind of questions will come in the board exam. We need to know that first. Okay, once we get to know the this one question, what type of question, we will get that confidence. Once you get the confidence, you will definitely get good marks, and you will not be nervous during the exam time. And while explaining, I have used many keywords. Those keywords you have to use in the exam to get perfect mark, or else if the keyword is not there, they will never give marks in physics. So after all these things, go for the theory solution, after that numerical solution. Thank you.